Bismillah ar-Rahman ar-Rahim. Wassalamu alaikum wa rahmatullahi wa barakatuh. This is one example of designing logic circuits. I have here, of course, you have to read the question word by word and understand what's needed from you so that you can solve the problem. Design a logic circuit that sounds an alarm if guests violate empty chair requirements during the coronavirus pandemic in a 3-chair sample. To be specific, the alarm will sound off if 2 or more people sit adjacent to each other. So to summarize the problem, I have here 3 chairs. This is what's written in the statement. So I have 3 chairs. This is chair number 1, and this is chair number 2, and this is chair number 3. I will call them A, B, and C. And we will assume that there is a sensor on each of these sets. So this is a sensor. In specific, this is a pressure sensor. This is called a piezoelectric sensor, to be specific. I have here a picture of that sensor. This sensor will simply give you if you apply pressure to the surface of the sensor, then you will see some voltage in the voltmeter. So this is called a piezoelectric sensor. If you apply pressure, then you will see some voltage. So we will just assume that we have a piezoelectric sensor in each one of these chairs. Okay. And then if the chair is occupied, so let's say that this one is occupied, for example. If this one is occupied, then here you will get a logic 1. Okay, let me see. I think this color is good. And if this chair is not occupied, then we have a logic 0. And if this one is, let's say, occupied, okay, if this one is occupied, then the piezoelectric sensor will give you a logic of 1. So we will design a circuit. We will connect these outputs. Let me move these numbers out of my way. What we will do is that we will design a logic circuit in here. And this circuit will have only one output. Okay, and this output is either a 0 or a 1. In this case, I have 1 in here. So they are not sitting adjacent to each other. So in this case, the output here will be 0. So the alarm will not sound off. So here I will connect an alarm. Okay, whatever, maybe just a speaker. Okay, so this speaker now will sound off if I have a logic of 1 in here. Now, if you are implementing this circuit in the breadboard, of course you need to take care of the power, because you need some amplifier here. This logic is very low, and it might not be enough to power your sound alarm on. So you might need some extra circuitry, but this is not of our concern in this subject. We only want to design this circuit in here. So let's see now how we are going to design this circuit. So in this case, you have 3 input and 1 output. I will call the output F in this case. And you need now to fill the table, the truth table, where all the possible inputs. So I will call this step 1 just to make it more organized. So this will be now step 1, and step 1 is to construct the truth table. And this of course is after step, let's say step 0, and step 0 would be to let's say يعني understand the problem and read the problem statement very well. So now this is step number 1, okay, and it is to construct the truth table. So I'm going to write the truth table, and these steps, to be more specific, are to design a logic circuit. So this is what we are doing. We are designing a يعني logic circuit. Okay, designing logic a logic circuit, logic circuits, let's say, steps. So step number 1 would be to construct the truth table, and of course you need to fill this with all the possible inputs, and because we have 3 inputs in here, we know that we will have 8 possible combinations. That's 0, 1, 2, 3, 4, 5, 6, 7. Okay, and I have it over here, but I will just do it here with you. So as we learned in class, you can fill that by filling the first column would be 0, 1, 0, 1, 0, 1. Something is wrong. 0, 1. Yeah, I put 0, 1, 0, 1, 0, 1. And the second one, of course, the last row will be 0, 1, 1, 1, and the first row will be 0, 0, 0. And this will have 2 zeros, 2 ones, like that. And the last one will have 4 zeros, 1, 2, 3, 4, and 4 ones, like this. Okay, now the alarm, you want the alarm to be on if you have 2 adjacent people sitting to each other, and these A, B, and C are assumed to be in adjacent positions. So let's say, for example, not for example, so this one will have an alarm, okay, because I have 2 adjacent people. Here I don't have adjacent people, here I don't have adjacent people, here I don't have adjacent people, here I have an alarm, and in this case I also have no alarm. In this case I have no alarm, in this case I have an alarm, and in this case I have an alarm. So these are the 3 possible outputs in which I want to write the min terms for. Now the next step, this is now step 2. Okay, I will type it here, and then I will drag it to the bottom, and we used yellow. I'm looking for yellow. Okay, this is yellow. Okay, now for step 2, you want to write f in terms of min terms. This is what you want to do. So clearly here you have a 1 in these 3 cases only. So these are the min terms that are interested for you, or interesting for you, I'm sorry. And the min term for this one will be a bar, and it is a bar because we have a 0 in the A column in here, and it will be B and C in these 2 columns because I have a 1 for the column B and 1 in the column C. Okay, similarly this will be A, B, C bar, and this will be A, B, C. So in this case my function f will equal to A bar B, C, or A, B, C bar, or A, B, C. Okay, so this is now step 2, and this is called the canonical min terms form. So I'll just drag this down in here. This is now step 2. I wrote the function now in terms of min terms. Like this. Now we know this is not in the simplest form, so we want now to simplify this expression. Step 3. You want to write f now. This is an e in here. Write f in the standard form. Okay, and there are some, you can write it also in terms of max terms, max terms, but we did not take this in class yet, so I'm not going to explain this one. And for the standard form, we have two forms. We have the sum of products. Okay, you can write it, if you wrote this in terms of max terms, the f, okay, then you can write this in terms of product of sum. So we have two standard forms, sum of products and product of sum, and we have two terms, we have the min terms and two canonical form. So this form is called the canonical min terms. Form, sum of min terms form, canonical sum of min terms form. This is what this form is called, because it's a sum of min terms. These are min terms and I'm summing them, so it's called sum of min terms, canonical form. Now the next step is to simplify this. If we can't simplify this, then we reach to the standard either sum of product or product of sums. Now there are two ways to do this procedure, two ways to simplify the forms, either by Boolean algebra and the postulates and the theorems of Boolean algebra, or by using the K-map. K-map I will not do today, but we will do the so here I have two methods, and this in specific is the method that I'm going to use today. Okay, so I'm going now to simplify this term using Boolean algebra. To simplify f to the standard form, what we will do, so this is f, we note first that we can take ab here as a common factor, so I have a bar bc plus I have ab, and then this is ANDed with c or c bar, which is 1. Now here again I can take b as a common factor, so this is now b, a bar, c, or a. Now next I can distribute the addition over the multiplication, so this will be b, and then I have a or a bar, a or a bar, okay, ANDed with a or c, and a or a bar is of course 1, so this will be, and then I have b times ac, so this is simply ba plus bc. And we note in fact that this is, yes, BA plus BC. We note in fact that this is a, well, that's actually interesting. Let me write this here. A or A bar is equal to 1, so this is now B, A or C, okay, and this is BA or AB, let it be AB or BC. Okay, this is in fact is a trivial solution that you can if you went back and look at the problem, it is clear that if BC is ones or AB is ones, then this is equal to 1. I did this using the K-map in here, but it's solved in this problem. Let's do it using K-map as well. So using K-map, I have what? I have A in here, let's say AB in here, and C in here. And then this should be coded using the okay, I need 4. This should be coded using the gray code. So this is 0 0 0 1 and then 1 1 1 0, and I have 0 1 in here, and the ones are at 3 6 and 7. Okay, this is 3 0 1 1, and this is 6, and this is 7. Okay, so simply we can group these together, and this will give you AB, the term AB. And I also can group these two together, and this will give you the BC. This will give you BC. So the result is, of course, as expected, is the same. AB or BC. So now this is step 3. I did already derived the function. Now after that, what you can do is, or what you should do, step 4 in here, is to implement this function. And to implement this is very easy. Let me go to this mode. I have 2 AND gates. Okay, so this is one AND gate. Okay, like this. And the inputs here are A and B. And then I have another AND gate like this. And the input here are B, so I'll take B from here. And then I have also C. And then of course I have an OR gate. So what I'm saying is that it is true that this might be a trivial solution for this specific problem. It's not always the case, of course, but for this specific problem it might be a trivial solution. But this is a standard procedure that you can follow step by step, and it will lead you to a solution. So of course after that, what you want to do, this is from before, this is actually a mistake. Let me take this out. Okay, let me delete this. Also there might be a more advanced solutions. So this is now step 5. Step 5 is to implement this using the multisim or logic works, and make sure that it's working. And after that, of course, the circuit is implemented on PCB. There are some advantages and disadvantages to designing to this circuit over the more advanced solution, let's say using Arduino. This should be very cost efficient and very fast, because this depends on electricity. It's only switches on or off, so this is very quick. So it has a very quick response. It can be printed on an IC in an extremely small size. Of course, that's not might not be feasible if you are doing only one circuit, but if you are doing like mass production, like you are producing like millions of circuits that implementing this function or this project, then it might be cost efficient and a feasible solution to print this on as an IC. But of course, this is very hard to maintain. If one of these gates is broken, then you have to change this, and it might not be very as easy as changing a line in C code or something like that. So this is it, and this is just from before. I hope that you find this video useful, and best of luck. Assalamu alaikum.